This board can track you indoors only using Bluetooth. Let's get into how it works. So this is actually for a project presentation in my 4900 class in college called IoT and Mobile Computing. The goal here is to find a better way to track location and distance indoors. Now, there are alternatives such as GPS, which is used, but when you're indoors, there's a lot of other things that create radio frequency and noise that make GPS indoors very unreliable. For example, we have your Wi-Fi, we have Bluetooth connections around you, and Bluetooth interference. This board comes in the development toolkit from Silicon Labs. It's approximately $300 and includes a main board and also a direction finding pro kit. So it comes with the BG22, the array board I was showing earlier. With Bluetooth 5.1, the calculations for angle of arrival have gotten easier. We can calculate angle of arrival due to the antenna array board supporting Bluetooth 5.1. We have a transmitter here that utilizes Bluetooth low energy. Now this tag right here can be powered with a CR32 battery module or through USB. Bluetooth low energy is what it sounds like. It's really low energy. Nowadays, this 2200 milliamp battery pack can charge most of a phone, but when it's connected to this Bluetooth low energy transmission chip, it can run for almost a week. Now, why is this important, right? Angle of arrival is used in a lot of different use cases. Hospitals, restaurants, smart home devices, or assistants and assistant tracking. By just plugging this in, I can power the device and you guys can kind of see it blinking. That's how we know it's on and working. And this is a really old battery bank. I don't think it still holds a 2200 milliamp battery charge very well, but I've had this sitting on my desk forever and it just continues to work, which is awesome. During the production of this project, I haven't had to recharge this once. So that kind of just tells you how efficient these BLE, which is short for Bluetooth Low Energy devices, really are. Let's talk about the hardware architecture. So this BTE transmitter basically sends a CTE signal into the locator, or in our case, this antenna array. Once the antenna array picks up a signal, it uses the best antenna array to find where the signal's coming from, and then from there, this main board is what is used to convert and calculate things like distance and direction. Now, it's not as simple as just that. There's a library called RTL, and that's what actually calculates the angles and angles of arrival. But again, that's a little bit more software based. Also, for things like triangulation, that's only possible when you have multiple antenna arrays. It's not really applicable for just one locator. In our example, this 16 array board that we're using. Okay, so this part of the project was kind of weird. I had to download this Gecko standard development kit, and there are certain parts and applications within the Gecko SDK that need to be compiled on your system so that the executables work. So because of that, I tried doing it on my MacBook, and I ran into some issues because it's in C, and for some reason the GCC compiler wasn't outputting an executable for me to use. And because of that, I decided to go to my Windows PC and do it from there, and that worked great. The repo is in the description below, and it includes all the steps I took to get this up and running. Also, there's two specific applications that had to be compiled. One of those being the BT AOA host locator, and the other being the BT host position. Basically, if you don't have any C experience, it's okay. They created some make files. So you just run make export. Then once that's done loading, it'll create a directory in your present working directory called export, and then you'll CD or change directory all the way down, and then you'll get back to your either BT AOA or the BT host positioning. From there, you'll just run the make file, and then it'll generate the executable. Once the executable is working and you can run it in the terminal, that's where the fun part kind of starts. You'll download a program called Mosquito, which will help you decipher these MQTT packets that are being received by the locator. You'll then run the Python visualizer, which is just another representation of the distance and angles that are found, which you can kind of see in Simplicity Studio if you don't want to compile all that. That's kind of how it works. We'll get started and explain more on the PC. All right, so now that we're on the PC, I'm going to go ahead and plug in our power to our main board. and it'll load up on the Silicon Labs screen right here. And we also have our, again, Bluetooth antenna array, so it'll be powered. Y'all can see there's probably a light. Yeah, there's a light right here to show it being powered. Y'all can see that. So that's kind of how we turn it on. Once you have the workspace here, you can see that this kind of popped up. It should just automatically pop up on your computer. So when you open it up for the first time, you have to install these firmware updates so that the hardware can communicate with Simplicity Studio. I'm not going to show that in this video because it's all in the repository and you can follow that step-by-step guide. But once you get there, you're able to open up the AOA analyzer. We're going to do this for the legacy board, and then it's going to kind of look like this. This is how I'm connected. So I'm going to connect via USB, and then we're going to choose COM6 since that's the port. And as you can see now, our, I guess I'll show the camera over here, but as we'll probably move this so it represents clearly kind of where we are at. But as I have the Bluetooth array, you can see the arrow moving depending on kind of where we're located. And let me zoom out a little bit on the camera so y'all have a better idea of how this kind of works. And yeah, this is pretty cool. And again, this transmitter could work for kind of weeks at a time. It seems like it is a little laggy, but that's okay. So right now we're capturing in real-time high accuracy mode, and that means that it will update really fast. There's different modes as well. So another example would be going to one-shot basic. If we update this, it's going to be a lot more choppy. Again, it's one-shotting using the MQTT packet, the CTE packets. And yeah, you can change kind of what mode is done. You could do real-time fast response, and we'll update it again. And it gets a lot more jittery just due to uncertainty. So you can kind of mess around with this one-shot azimuth only. So it's representing only the direction and not the distance. So only the specific two-dimensional, degrees. We'll go back to real-time accuracy and update it. And yeah, that's pretty much what the demo shows. So yeah, that's pretty cool. Also, again, it picks up things like elevation. So right now we're at 70, hovering around 70. If I go all the way up, let's do it like all the way up. You guys can see my hand all the way up here. Now it's at 81, 82. And then if we go back down, we're back to 70 over here. So yeah, pretty cool things, pretty cool stuff. So now that the system works, we're gonna connect using the code that I have. So again, over here is what it kind of looks like when Mosquito's running. So let's go into Task Manager and just double check to make sure Mosquito's open. I think I just saw it down here. Mosquito has to be running for this to kind of work. So we have Mosquito running. We also, now we can run our Python file, which is right here. And by running this file, we can kind of see, make sure when you run the file, you provide your config for position. Now make sure that your Bluetooth locator ID is the same as the transmitter. Not the transmitter, the same as the array, otherwise it won't pick it up. But once we run this, we have a Python graph right here that is three-dimensional, and from there, we have to run the locator. So we'll run the locator here. Great, the new tag was added, and we have the tag ID right here as well, showing that Python did see it. And in our visualizer, we can see just how it looked on the Simplicity Studio, kind of where it's going from there. And we can obviously change the direction if we want to go this direction, or the farther you go back, the longer this line will get. Showing distance is working as well. And then also we have an experiment to conduct related to distance and elevation and azimuth and things like that. So what we're going to use is we have mosquito sub, which is a executable that Mosquito gives, and we can run that just like this, and we'll get a constant stream of values that relate to the where the locator is seeing the transmitter to be. And yeah, we're going to kind of use that information, pipe it or move it into a file, and then from there we'll create our visualizations for that. So yeah, let's get started on that. All right, guys, for the first part of the experiment, I tried to think of like a control group, but if this isn't on, there's no MQTT data being shown. So like, we're probably just gonna do just like a test walk, I guess. So I'm gonna go ahead and unplug this from power. When I do, it's gonna stop moving right there, which is normal. That's okay for the, I guess, control group. How it's gonna work, I'm gonna be outside the door, and then I'm going to, the door's gonna be closed. I'm gonna open the door, walk in. You'll see it in the control run. So I'll be outside, door closed. Door will open. Yeah, that's pretty much it. So 7 seconds of walking. It'll be exactly like that. And let's get started. So our first part of the experiment, we're gonna do with it in my hands. As you can see, the Bluetooth device is now working. The Bluetooth is transmitting those CTE signals, and great. So I'm gonna hold it just like this, and I'm just gonna walk with it like that. And yeah, let's get started. I almost forgot to start piping the positioning. All right, run it. All right, cool. Let's get started. All right, great. So that was run 1. I'm actually gonna do it 2 more times, just so it's accurate. Doors open, 1 is open. All right, cool. And that was part B. All 3 are done. Now that we have it where I'm kind of just walking with it, what we're now gonna do is we're gonna take the Bluetooth transmitter, and we're gonna put it in my pocket right here. We'll put it here on my left pocket, and then I'll put this right in my right pocket. And basically, I'm just gonna walk like this. What this is supposed to kind of capture is the difference between how I'm doing my hand movements and then maybe just the movements of my leg. Okay, and then we'll go outside. Great. So that was test 1. Now we're going to do it again for test 2. Again, we're doing 3 more of these as well. Let's start rolling. Okay. And then last test. All right. All right, guys, that kind of sums it up for the video. I hope y'all enjoyed. Again, the repo, the how-tos, everything is linked in the description below. I'm also going to have on screen right now the graphs that have been generated, and that's also going to be available in the README. But yeah, hopefully y'all enjoyed. I'll see y'all later.